Hi there. Today I'm gonna fry some gushu leaves, the second batch of this spring 2020 season. You can have a look. It's very nice looking leaves, very green, very dark green and quite tender enough. We got them from Gongjin. That's the tea garden that's just above the village from which you can see the temple. So let's start now because my work is really hot. It's 340 degrees Celsius. Usually I like to start around 300, so I'll have to be quick at the beginning. So let's go. So today I'd like to talk about an agricultural subject. As the years passed, I've noticed that the yields are decreasing. So I feel like every year we just blame the weather for that. But I think this year in 2020, the weather conditions were pretty good for having good harvest. We had warm weather at the end of winter and quite a lot of rain in the very early spring and late winter, so we can't really say that there's a drought this year. And yet our Shanghai, our natural tea gardens, aren't giving much leaves. Like, we're on March 25th and a lot of tea gardens haven't sprouted yet. Actually, it seems like the Shanghai now are sprouting at the same time as the gushu, which is unusual. In the past they would, like, you'd get first the Shanghai as early as mid-February, and the peak production of Shanghai in mid-March, and then you'd get the gushu 2 weeks later. But this year it seems like it's gonna be at about the same time. We're still waiting for that peak season for the Shanghai. So I'm starting to think that if it's not due to a lack of water, the low yield might be explained by a lack of nutrients in the soil. And that would make sense because those natural tea gardens haven't been fertilized for about 10 years. So that's the 10 years since the time they were converted to a natural tea garden. In the past they used to be conventional taidicha, intensively managed plantations. And since that time, like, the word fertilization, like Phosphate, it's become a taboo word really among the tea producers. Like, there's no way you're gonna say you fertilize your tea gardens, because no one will buy the tea if you say so. It's just as bad as saying that you spray pesticides. And so I think it's a bit extreme, because well, think about it. Every year you're just harvesting leaves, so you're taking nutrients out of your field. These nutrients come from the soil. So every year you're depleting the soil from the nutrients, and at some point you need to add some. So today I'd like to talk a bit about the nutrient cycles and how nutrients are added in the cycle. You could think that in a natural ecosystem, an ecosystem in which nothing is harvested, you will have you will have a stable amount of nutrients in your system. Like, you won't take nutrients out of your plot. Some nutrients might leach, like, for example, the rain will carry some clay away from the field, but usually you will get as much clay from above than you lose to the valley. The big losers in this is the top of the mountain, and that's why the top of the mountain is not fertile, because it's giving its clay to everybody else down and is receiving nothing. So that's why you have no you don't have, well, it's hard to do agriculture on the top of mountains because they have the poorest soil, almost purely sandy soil. And then you will find the richest soils in the deltas, as near the sea, because, well, think about, like, why are there so many people in Bangladesh, for example? Well, it's because they have great soil, because they get all the clay from like the Himalayas and all the hills along the way. So when you see that the rivers are red, it's because they are carrying all that clay with them. And it's a clay that's charged with nutrients, so it's free fertilization. Now here, we could say that tea is grown at mid-hill, so you could say it's the worst kind of soil you can do agriculture on. That's why we only plant tea, because tea, just like rubber trees or coffee, it doesn't require as much nutrients as, say, rice or corn. So that's why such a crop is grown at fairly high altitude, and all the cereals are grown more in the valley, in more fertile soils. Well, since the beginning of agriculture, the challenge has been to get some nutrients. So that's why agriculture started a lot on the banks of rivers or in deltas, where you would have free nutrients given by the water that came from uphill. So what do you do when you don't have access to water filled with nutrients? Well, you can, for example, use animals to transport the nutrients. So a common practice, especially during the Middle Ages in Europe, was to they had some common grounds on which the animals, all the cattle, would graze, and then at night they would park them in another area, an enclosed area, and usually the animals would defecate at night. So you'd collect the manure, you'd collect most of the manure in a specific place. So basically, the animals would go collect the nutrients from the grass in the natural areas, in the common grounds, and then you could use the manure for fertilizing your plots of lands. So that's a way you can use animals. When it comes to nitrogen, for example, you can also use some plants that will fix nitrogen from the atmosphere. Then later on, around the 17th century, if I'm not mistaken, we would start mining these nutrients. At the beginning, it started during the age of sailing, when explorers would find islands with big layers of bird shit, actually. So imagine a small island and you're a bird on it, so you're gonna go out fishing, catching fish in the ocean, and then you'd go back on your island and defecate. And if you do that for 10,000 years, 100,000 years, well, if it's a small island, you know, all the shit will accumulate on the island in layers. So basically the whole island was just bird shit. And at the beginning it was very easy to mine, and you could say it's very highly concentrated nutrients in that bird shit. So that was very useful, and it led to some increase in yields during the Renaissance in Western Europe. Thanks to this, this is called the guano. So that's how we call this type of fertilizer. But this resource has been depleted for over 100 years now, because of course it was pretty easy to get, and it was low tech, so everybody used it, but it was fairly limited. Then for things like phosphate, potassium, calcium, magnesium, things like that, nowadays we mine it. Just in mines we find rocks which have like high phosphate content, and we just grind them and do some processing to extract it, to extract the pure phosphate from the rocks. And for example, for phosphate, we were very worried about 10 years ago, because at that time we thought that there was only like 40 years of reserves left at our current consumption. And lately they reviewed the total quantity available, and they found actually a lot of phosphate rocks in Morocco. Morocco has like 70% of the known phosphate reserves in its ground. And so that's the good news. I just checked today, and they say, like, they estimate we have like 260 years of phosphorus available in the ground, as far as we know. No, it's a lot, but there's a problem with this one, is that once it's gone, and it's really hard to get it back. Actually, we can recycle it on land, but once it's gone in the ocean, we won't. Well, it will be very hard to get back, only through fishing or, I don't know, growing algae, things like that. And it might be a problem in the future, because it's more worrying than oil, because you could say that you can replace oil by another form of energy, but you can't create phosphorus, and you can't replace it by anything else. You can only extract it from the soil. No, there are huge reserves, but they are deep in the earth crust, and we don't know how to extract them economically at this time. But yeah, we have like maybe 200 years to solve the problem, so we could say it's not a big current problem. But it used to be 10 years ago, so that's interesting. When it comes to fertilization, most of the time we talk about nitrogen. It's because nitrogen is very unstable in the soil. It leaches very easily. Like when it rains, it's very easy for the nitrogen to leave the soil. Not so much for all the other nutrients. And nitrogen has quite a different cycle from all the other nutrients. The other nutrients are just found in the ground, and we just extract them from rocks. But the nitrogen is not in the ground, it's in the atmosphere. You know that it's like 80% of the atmosphere content is nitrogen. But of course it's in a different form. It's in the N2 form. It's a gas, and we like it as a liquid, like ammonia, like NH3 or something like that. So in the past, the only way to get that nutrient was to use legume plants. So that's why you would have crop rotations. You would let your plot rest for some time so that it could regenerate its nitrogen resources. If you want to speed up the process, you can plant legumes, and that's very usual to do, at least in France, like to do a cover crop, what we call cover crop during the winter. So between the two main crops, like you're gonna grow wheat, and in between you will plant some legumes that will fix some nitrogen from the atmosphere. So it's a pretty good technique, which is often mentioned, you know, in agroecology. But the thing that most people don't know is that they are not magic plants. And like all plants, they are somewhat lazy. And the thing is, they capture the nitrogen by doing a symbiosis. So let's say an alliance with a little fungi. But it costs them a lot actually to do this. So it's a less efficient process than just taking up nitrogen through the roots. And they will only do that if there's no nitrogen available in the soil. So the nitrogen fixation function of the legume plants only works in poor soils. Like if you have a lot of nitrogen in your soil, you plant the legumes, but they won't add any nitrogen. They will just suck up what's in the soil. Now in early 20th century, we managed the process, the Haber-Bosch process. It's a process in which, like, when you put the nitrogen, the atmospheric nitrogen, under high pressure and high temperature, then it somehow becomes some liquid ammonia, and then like you can process it into fertilizer that's usable by the plants. And that's what we typically call chemical fertilizer. It's like nowadays those little white little balls that you just throw on the ground. So that white little ball is just a matrix. It's just a structure that's designed to contain the ammonia, and it's designed to decompose over time, so that you don't lose too much nutrients through runoff. So maybe some will take like 3 years in the soil to totally decay and slowly release their nutrients along the way. But of course it would depend on the type of matrix used, and most importantly the conditions of your soil. Like if you're in the tropics with high temperatures, it will surely decay faster than if you're in a cold country. And this Haber-Bosch process has revolutionized agriculture. You could say that the increase in population, in global population, wouldn't have been possible if there hadn't been that process invented. So that's a pretty cool process, because we get virtually unlimited resources of nitrogen. But it consumes a lot of energy, because as I said, you need high pressure and high temperature, and it's very energy intensive. So I checked, and that process alone uses up to 2% of the world energy production in 2020. So you can think like that's a lot of energy. But it's thanks to this that we have no food shortages nowadays. Because I like to talk with elder people in Jingmai and other areas, and when I ask like, why didn't you have food in the past? What was the problem? Well, they all say we didn't have any fertilizer. So when you don't have fertilizer, you don't get any new nutrients in your soil. So it means that you have to recycle as much as possible. So for example, you will do like the Middle Age technique, like having cattle grazing in some wild areas to gather the herbs, and then have them rest in the field you want to fertilize, or in a place where you can collect the manure, and then spread the manure in the field. And it takes a lot of work actually, just gathering the animals around and manually handling all the manure and putting it in the field. Or you could do slash and burn. You would just burn a piece of natural forest. You'd get all the nutrients that were embodied in the trees and plants. They would go back on the ground. You just burn the carbon. Only remains all the nutrients. Then you can grow your stuff for a year or two, and then you don't have any nutrients in the soil. So you let the soil rest. The forest somehow recovers, and after like 20 years you have a new forest. You can burn it again. So you have to rotate between different plots. So this process usually involves a semi-nomadic lifestyle, because you need such huge surfaces of land for that to be viable, that it's hard to stay in one village and do this. You will maybe have a couple of places in which you will build temporary houses, stay for a couple of years, and then move. And like in Laos, where we do the consulting work, people used to be like this, and they were sedentarized quite recently, and it really involved a change in their agricultural practices. Okay, so we have like grazing, like association between cattle and crops. That's a way to get the nutrients. We have slash and burn, so you could say you somehow get the nutrients from the ecosystem, from some very long-term processes that will renew the nutrients, and you can get through irrigation, but of course only in some somewhat limited places. And so in the 50s came the Green Revolution. I said that process of making chemical fertilizer for the nitrogen was invented in in the early 20th century, but it got really widespread after the World War II, because at that time we had a problem for food production, and we needed to produce more food. So a lot of engineers gathered, and they established new agricultural practices. Under those practices, the soil, the environment wouldn't matter much. What would matter would be the inputs you add in your field. So the idea was that you could grow anything on any soil almost, as long as you add the proper inputs. And that allowed some standardization of the agricultural practices. And with standardization comes economies of scale, and that's how we multiplied the food production several fold, and really stopped those common famines and starvation. So it's easy, you know, for people nowadays to look down on those use of chemicals and pesticides, and you know, to say that the Green Revolution caused pollution and everything. The Green Revolution solved a huge problem, was that the world was hungry, and it succeeded at this. So I hope our generation will succeed at that, what we call the second Green Revolution, the revolution that's supposed to make agriculture cleaner towards the environment. And it's with that objective in mind that the local governments in Yunnan decided to make those natural tea gardens. The Taidicha, the conventional tea plantations, were made with that Green Revolution mindset. So the objective was to have a huge yield, okay? And there wasn't much concern for the environment, because that was just a foreign problem at this time. Nobody would understand what ecology was and what was the point of ecosystem services, things like that. So those techniques involved a lot of fertilization, and like in many cases in industrial agriculture, too much fertilization actually. So I read that they estimate that about half of the nitrogen put in the field doesn't get in the crop actually. Half of the nitrogen in the world runs off in the water bodies. So when we say that chemical fertilizers are bad, they are mostly bad for the environment outside the plot of land that's cultivated. I would say it's more the use of chemical fertilizer that causes damage than just having fertilizers. If you make a proper use of chemical fertilizers, you won't have much pollution. The big part of the pollution is the runoff. So all the free-flowing nitrogen that goes in the water streams, and then might cause eutrophication. So eutrophication basically is just when there's a lot of nutrients in the water and there's a lot of food for the algae, then the algae will bloom, they will reproduce a lot, then the water will be muddy, will be troubled, and then the light won't penetrate the water, which means that it will kill all the bottom plants. And if the small fishes don't have food at the bottom, they won't grow. So basically you have that algal bloom that kills everything and makes the water troubled. You can find this problem in the Baltic Sea, for example, or in many lakes all around the world. And so the way to avoid that problem is to better control the fertilization in order to limit the runoff of nutrients. And I think everybody agrees on limiting runoff, you know, because it's just a waste of money and time for the farmers too. Okay, I think my wok is ready now, huh? Yeah. I started with a very high temperature, but in the end it was okay. I don't have too much in the wok now. I only have 7 kilo. Well, it's just because I had like, how much? I had 21 kilo of tea to process, so I just decided to make three woks. Could have done two, but it would have been more tiring and quite a lot of steam to evaporate, so I went for the safe way. And anyway, you know, I'm not too busy at this time of the year, so why not process three woks instead of one? It's getting a little bit dry. Actually, I processed the first batch of gushu that was from the same garden yesterday, and the tea was really good. Honestly, I was really happy. A lot of huangpian in the tea. Maybe it's also because I like pushing the cooking, so the longer you cook, the more huangpian you have. But I think it was worth it, or at least now I was quite happy. So I hope this one will be as good. So I'm just gonna change the batch, and well, then I will continue. So here is my last batch of the night. So there's 6.5 kilo of the same material. So let's get started. So there are two types of fertilizer, two main categories, organic and mineral. When I say organic fertilizers, it means that it's mainly carbon. It has nothing to do with organic agriculture. Organic just means made of carbon. So organic fertilizer is mostly made from carbon. It's manure or compost or mulch, things like that. It has a very low nutrient content, so you need to apply tons of it for it to have an impact on the soil. But the good part is, since you have a lot of organic matter in it, it will increase the water and nutrient retention capacity of your soil. It will make your soil better. Organic matter is important because it will bind with the clay in the soil to form a complex that will be able to hold more water and nutrients, just because of the structure of this organic clay complex. So that's why we say organic fertilizer is good for the soil. It's because it improves its quality. But it doesn't add much nutrients in the soil. To add a lot of nutrients in the soil, you have to use mineral fertilizers. So mineral fertilizers, they can have a low carbon content or no carbon at all. So it was the guano that I explained at the beginning of the video. It can be, well, nowadays it's mainly what we call chemical fertilizers, so nutrients extracted from mines, nitrogen made through the Haber-Bosch process. So this is little white pellets that you throw in the soil. You also have alternative sources. For example, you can use fish bones, crushed fish bones, which have a low carbon content but a lot of nutrients in them. And I would say, to get the most efficient fertilization, you need to use both. And often we criticize chemical fertilizers because the way they were used and are still being used widely in conventional agriculture. Organic fertilizer is harder to get, and more importantly, it requires a lot of workforce to apply, because you need to apply tons of it. While mineral fertilizers, well, you need maybe 10 times less, or even less than that for a same surface. So in most places they decided to rely solely on those chemical fertilizers. And what happened is that you had a drop in soil quality, because every year you lose organic matter in the soil because it is consumed by all the microorganisms in the soil. That organic matter, that carbon, is food for the microorganisms. So every year you will lose some carbon content in your soil, and so you're supposed to add some carbon content every year to keep it stable. Now, when it's not done, you will lose all your organic matter, and then you will lose the soil quality, the water and nutrient holding capacity. And what happened in many places is that by only putting chemical fertilizers, well, the soil had very low nutrient holding capacity, so most of the fertilizer they put was just running off. So then that's a big waste of resource, and that's what creates eutrophication downstream. If you use only organic fertilizer, you will have a great quality soil, but having that nutrient holding capacity doesn't mean you have the nutrients inside. Okay, that soil quality is like the size of your fridge, and then the nutrient content is how much food you have in it. So you can have a big fridge with few food in it, and that's what happens when you only use organic fertilizers. So I think in the future the most efficient way, the best compromise, is to use a bit of both. I would say to use mainly organic fertilizer to keep that soil quality, and occasionally add some mineral fertilization. Either you add it once every few years, either you add it every year but it's in very small quantity. So there was a lot of misuse of the chemical fertilizers because despite consuming a lot of energy, they are relatively cheap, especially compared to organic fertilizer. And so many farmers tend to put too much of them. You can calculate how much nutrients you need, like how much nitrogen you need. You just need to know the nitrogen content of your crop, or that approach works with any nutrient actually. Then you need to know your yield, so how much crop you will export from your parcel, and then of course you can calculate how much of the nutrient you need to input in the field. Now of course you don't have a perfect yield, so you have to account for all the runoff, the leaching, lixiviation, things like that. So some nutrients run off with the rain, some nutrients go too deep in the soil to be captured by the roots. Some nutrients can also evaporate, and nitrogen actually evaporates, and it can create air pollution. It creates the NOx, NO, NO2, NO3, the ones that are also produced by the airplanes. They're not produced in big quantity, but they have a huge greenhouse effect. They are greenhouse gases. So, but you can avoid all these problems if you use these rationally. And I would say nowadays that's where modern agriculture tends. They want to what they call like rational, like reasonable agriculture. So in this type of agriculture, we will keep using all the modern tools available, the fertilizers, chemical fertilizers, pesticides, GMO crops, things like that. But we try to use them in a rational way. Like we try to use them thinking about reaching the best compromise between environmental impact and yield and quality and food quality. So this is a bit different from the natural management approach that's been taken in Yunnan for the tea cultivation. Nowadays in Yunnan they say no fertilization at all, or in some areas they only fertilize with organic fertilizer. But maybe this paradigm will change. I wouldn't really see the problem in using a little bit of mineral fertilizer, whether it's of a chemical origin, well, of the Haber-Bosch process or from mine, or from some alternative sources like those fish bones. The fish bones are a good alternative because they are like the only way to catch the nutrients back from the ocean. So you could say that that's like the only sustainable way of getting nutrients, because eventually all the nutrients flow to the sea, and by getting the fish bones you can get them back. That's the only way. But of course these nutrients are available in very, very tiny quantities. And so it raises another problem. Consumers want to buy organic products, things that are not made with chemical fertilizers, for example. But I would argue that all the food that's grown, including the organic certified food, has like chemical fertilizers have been used to produce this food. Because, for example, when you use organic fertilizer, well, let's say you will use a mulch or some compost. What was used to grow this mulch? Like, for example, if you use rice straws, we could use rice straws in the tea gardens, but we fertilize the paddies with those chemical fertilizers. If you use manure, well, how were the cows fed? How were the animals fed? Well, most of the time it will involve indirectly some chemical fertilizers. We rely heavily on them because that's the only way to really input new nutrients into our global system. As I said in the past, when people were starving, they could only recycle, mostly recycle the nutrients. For example, nowadays a big change is that we don't really use the wastewater as fertilization because our bodies are too polluted. For example, we take a lot of medicine which can be harmful to the soil. There are also studies on how to recycle all this wastewater and what we call the sludge, so all the solid matter that we get from the wastewater. And there are ways to clean that, but it's still, I feel like the farmers are quite reluctant on using them. You have to pay for cleaning them, and usually you will sell it cheaper than basic cow manure because people are reluctant on using this. The mining and the Haber-Bosch process, they are now part of our world. Like we couldn't sustain a high population of meat eaters by just recycling all the nutrients. So when people talk about the damages of agriculture, they tend to mix up a lot of different things. For example, the pesticide issue is very different from the fertilizer issue. Chemical fertilizers pollute outside the field because when they are not properly used. Actually, if properly used, you could say it's like the GMOs, you know? People criticize GMOs, but it's not a harmful technology in itself, unless you go into that ethics debate on how far we can modify the genetic of the plants. It's mainly that the first use of the GMOs, which has been like being resistant to herbicide, led to very polluting techniques of agriculture. Now, for example, we develop GMOs that will be able to grow on salty soils, and that will increase dramatically the amount of soil available for agriculture, because a lot of soils cannot be farmed because they are too salty. They also develop GMOs for improved nutrition. Now again, that's another debate. There are other ways to improve the nutrition in poor countries, for sure. But my point is, we tend to make shortcuts and blame a whole technology. Well, it's like palm oil, you know? Palm oil, the palm tree is a great crop for producing oil. It's a very efficient in terms of surface, because that's the best plant if you want the highest amount of oil per surface. Now, people don't like palm oil because of the way it's been implemented in Indonesia, but you know, like palm tree is a very common crop in all of Africa, and Africans use a lot of palm oil for cooking. So when talking about these environmental issues, it's really important Well, to try to know as much as possible on the issue, because these are not simple issues. I feel like there's too much resentment, some kind of anger towards the development of the world. And it's good to take time and study these issues to understand them a bit more fully. Now it remains that from a sales point, it would be hard in Yunnan to use chemical fertilizers in the field if the consumers know about it, because of course if the consumers know about it, maybe they won't buy the tea because they've heard that chemical fertilizers are bad. Just like if you use GMO crops or palm oil in your products, many people won't buy it. And so you can see that the end consumer actually influences a lot the agricultural techniques, the decisions that local governments and farmers make. Because when you think about agriculture, especially when it comes to products where the technique matters, like tea, like high quality tea, the consumer will have a huge power on how the crop will be grown, because eventually what matters is to sell the tea and not necessarily produce it in the most efficient way. Where the impact would be the most significant would be in the mass production of tea, where when people buy tea bags, they don't really care so much about how tea is grown. They are just happy to have like a Rainforest Alliance label, which is like total bullshit anyway, because it's very easy to get. It's just some corporate greenwashing, really, this kind of label. The good point of having low yield is that you get higher quality, and really this year I think the quality is pretty good. I'm quite happy. So it's not a big problem for me not to have a big yield, but of course my trade, I don't rely that much on having a big yield, because I can buy the leaves anyway, and I don't mind paying more for them because we are in the higher quality range. What I'm talking about is maybe more relevant for the middle range, you know, the ones who need to have decent quality, but also for whom yield is important. For example, all those plantations on the outskirts of poor city. Okay, now I'm gonna just keep the water in. I'd like to cook it a little bit. I think I got it a little bit dry, so let's just go on the side of the wok so that it doesn't heat up too much, and let the steam do its work inside. Now it's okay, I only have embers, but there's a lot of embers, so even if there's no flames, it's still a lot of heat going on in that wok. But yeah, I think the idea of very small inputs every year, I think that's the best way. Well, it's actually the proven best way to limit runoff, and so get most of what you put in the field absorbed by the plants. Now I guess there's also a lot of work on the matrix used for those chemical fertilizers. I'm not too knowledgeable about this. I guess it's a quite complex topic of chemical engineering on how to have that ammonia fit into those tiny pellets and have the pellets degrade over time. But yeah, I think anyway, from a rational point of view, you cannot have no fertilization at all, because every year you're taking something from your field. Maybe another alternative would be to plant legumes between the rows in the tea plants. I think that could be explored. I've never seen it done, but there's no reason it wouldn't work, especially if the soil is already poor in nitrogen. And I think that would actually be a great way to keep the nitrogen level low so as to have a high yield, because as I said, the legumes won't fix the nitrogen if there's too much in the soil. So you will keep your nitrogen levels low anyway in the soil. Otherwise, yeah, as I said, maybe organic fertilizer applied, maybe also complemented by some chemical fertilizers to add up more nutrients in the good structure we have in the soil. If we're into high quality and don't care about the cost, we can also use those alternative sources like fish bones. So I think that's it for tonight, huh? My tea is good now. I think it's gotten a little dry. Maybe I'm just gonna leave it in the basket for a minute so that I get all the steam that's in. I have it cook the leaves for just a minute. Yeah, I'm just gonna take them out because I can see them. They are getting dry, and if it gets too dry, really you will get some kind of greenish tea. I don't want that, of course, and you don't want that either, I'm sure, as poor tea drinkers. Yeah, so that's what we got for tonight. So thank you for watching the video, and see you later.